All right, so this is how you generate an error. And this is how you catch an error. You run this try statement, and then you say, and then you have an except. After the try block, you have an except that says, these are the errors I'm willing to tolerate within this. Make sense? Okay, so let me show you how this shakes out when you pass in a bad file. Right, so remember, this is all code we're running in countdist.py or ndist.py. So let me actually just go ahead and make a bad file. So let's see, I'm going to take E. coli ref 100k.fq and I'll just put it in badfile.txt, and I'm going to just edit bad file and put in, let's put in an M in my badfile.txt. If I now do Python or /ndist add file, what you'll see is now this value error. Now again, I've manufactured a file that has bad content, and I'm running the script on it and verifying that I get the mistake. Okay. No? Yeah, sort of makes sense. Okay. So let me show you a test runner. What we've been doing so far to run these tests is we've been running python utils.py, and I've changed the print statements. And at the bottom, the way that we know we're running the tests is that we have this if name equals main. So when this thing's run via Python at the command line, it runs all the tests. But we don't actually need this if we install py.test. So you may not be able to do this, depending on where you're running Python, you may not be able to do this, but if you type it, pip3 py install PyTest, that'll work. Let's see what happens. Whoops, Python minus Python3 minus m pip install PyTest. I'll get the command that works right. Okay, that didn't work. Pip. Oh, let's see. Okay, we're gonna have to install it for Python too. So, sorry, pip install PyTest. And what it does is it, in this environment, we already have it installed, but this will install the PyTest runner. And if you do py.test utils.py after installing it, it will actually run all three of the tests. Each of those dots that you see here is one of the test functions that we defined. And what PyTest is doing is it's going into utils.py, finding all functions that match test underscore, and running all three of them. So the two commands that I ran, one is to install. Let me do this here. Oh, that's the wrong link. Okay, I can just type it, pip install PyTest, and then py.test utils.py will run all three tests. So if you run py.test utils.py, you'll see that it's running all three tests. If you put a -v on there, it should tell you, let's see, it should tell you the names of the tests it's running. So the -v just says run them verbosely. Okay, so is everybody who wants to be caught up, caught up? Do we have, you have three tests in utils.py. Have I copied and pasted the latest utils.py recently? Let me just go, let me just do that.
I still don't understand.
Sure.
I don't understand how, if I just run utils.py that has that input, it has a bogus sequence that doesn't have a CGT and it does not raise a value error, even though it is calling countAnds. CountAnds has that raise value error statement there. So it passes that input test, but when that input test is run, nothing happens.
Yeah.
I don't understand how that's different.
Okay, so I just changed something in this test bad input function. So you see where it says print caught value error? So let me just show you that that works. But what that prints out, if I run now python utils.py, you'll see it prints out caught value error. So what's happening is that inside count ends, that error is being triggered. But then in the code that is calling count ends, I'm explicitly saying, hey, if this error happens, that's okay. Yeah. So it's explicitly about catching that error in this case. So this is generally the larger search term is this is generally around exception handling. The term is exception handling, where there's code that will trigger various problems, and you explicitly handle those problems that you know how to handle. Right? It may very well be that our count ends code will actually sometimes generate errors that we can't handle, and then those wouldn't be handled by the code, like an IO. I don't know what else. In this case, it doesn't. Okay. So okay.
So that assert false is with respect to that count ends.
So it's even worse. That assert false only will get run if no exception happens. Right. So it's the statement after the count ends function. If the count ends function succeeds, if it returns something and doesn't raise an exception, then that assert false statement will be run and there will be an error. Okay. So it's sort of this complicated logic where if an exception is raised, it jumps straight from count ends to value error, so that value error block. If an exception isn't raised, it goes to the assert statement, which will then fail. So just to demo that, if I come back here and I get rid of the broken sequence, and I run this, now you'll actually have an error because count end succeeded, and I expected it to fail. And that's because I changed, I had removed this. Okay. So this is called unit testing. And if you write reusable code in your modules, sooner or later, you'll find that it becomes handy to have these tests that you can run automatically on all of your code that's in modules. And if you don't, what you'll find is that at some point you change the modules and they break, and they'll break for some inputs on some code and not on for others on other code, and you'll have a tough time figuring, tracking down what breaks and why.
In terms of good practices, when you know
Yeah.
that you're going to be using PiTest or whatever, would you still include that statement at the end?
No, I would get rid of this. Yeah, I would get rid of this statement because it's just confusing, and you're going to forget to keep it up to date. Like you saw, right? I created a new test function and didn't add it, and then it didn't get run. And I had a false sense of security because I had a test, but the test wasn't getting run. So that's the value of the test runners, is that they just figure it out, yeah. And the nice thing, and I'm not going to demo it here, but the nice thing with the test runners is you can have 50 Python modules, each with their own set of tests, and pi.test will find all of them and run all of them for you automatically.
Do you usually put the tests in your modules, or can you have a separate file with all your tests saved?
So really good question. So the question was, do you usually put your tests close to the code, basically where they're testing, or somewhere else? So, and I did this sort of reflexively here. If I have a single module file and I want to keep everything in one file, I put the tests in that same file. As soon as I go to multiple files, like if I have a package, which I haven't shown you guys yet, but it's basically just multiple module files in one directory, then I start moving the tests into a dedicated set of test files. And part of the reason for that is that if you saw what I did with pi.test was I passed it a file name. I said test utils.py. If I have the tests broken out into different files, I can run subsets of them by saying pi.test this file, pi.test that file. And that's valuable. So for example, for the software that my lab develops, we have something like 1,000 tests that take a minute to run, right? And we don't want to run all those tests every time I'm changing a little thing. I just want to be like, hey, is there does this sort of work? And so I'll run a specific thing, or I'll write a test that I'm trying to get to work, and then I'll just run that test again and again and again until I get it to work. So yeah, so there's a lot of flexibility in how to organize your tests, but the key point is to have them. Okay, I'm going to show you something else, and let me see if I can. So try running pip install coverage. Okay, and coverage is a super handy program. I'm actually wondering now if this will all work. I think, okay, so I installed, let me make sure this all works, and then I'll go back and I'll run through what I did. So pi.test-h through less. Okay, I think maybe I can, I'm just going to Google it. How do I run coverage with pi.test? I think I have to do two things. So let me do pip install PiTest cov. And then I have to say here. It's pi.test-cov of equals prod utils.py. Does that work? No data was, okay. So this may fail. So let me show you, I don't know how to get it to work with a test runner, but I want to show you the concept of code coverage. So suppose I put those, suppose I put those test functions back in and I say coverage utils.py. Coverage run utils.py. Okay. Coverage report utils.py. I'll show you what all of this is, and then we'll go back and I'll help you generate it yourself. So what I've done was I ran some code. I ran a program that watches what lines of code are being executed, and it produced a report for me. Okay, this really isn't going to work. Again, the problem with not. There we are. Okay, so what the coverage report does is it tells me how many of the lines of code in a particular file are being executed, and it lets me visualize that. So here I ran utils.py, which ran those tests. And then what coverage did is tracked which lines of code were being in my utils.py were being executed. And here you can see I didn't run any of the lines of code in load sequences. And I ran all of the lines of code in count ends. And what this tells me is that I probably don't need to write more tests for count ends, but I probably should write some tests for load sequences. And I'm not really sure how to motivate that more, other than to say, if a line of code isn't run by my tests, then none of my tests test that line of code. If a line of code is run by my tests, all that means is that there's no obvious errors in that line of code. There may still be subtle ones, but at least it's being executed by some of my tests.
Sorry, I missed how you visualize it.
Yeah, so that's because I didn't tell you. So the way I'm generating this is I did this pip install coverage, and then I did coverage run utils.py, and coverage report utils.py. And that's the text version. And what this does is give me that. I can also generate an HTML output by doing this. And the problem now is that that gives you a directory HTML cov that you need to download somehow. And that's where the tricky bit comes in. And if you're using Binder, how many of you are using the Binder situation? Okay, if you're on your own laptop, you can just open HTML cov/index.html and you'll see it. If you're using Binder, you need to do something trickier, but I can show you later. So just to go back to the statements, what I did was I did pip install coverage to install coverage package. I did coverage run utils.py to run the code in utils.py while being watched by the coverage reporter. And then I did coverage report utils.py, or coverage report would actually just work, to report on which lines of code were run, and then coverage HTML to generate a directory HTML cov with an HTML web report. So typically what I would do now, I would look at that HTML report and I would say, okay, the red lines of code here are the things that I want to write tests for, because so far I have no tests of that behavior. And the green lines of code are probably adequately tested for now until I find bugs later on.
How are you doing this?
So it created a directory called, so this coverage HTML command that I ran at the end generates an HTML report that's in the directory HTML cov. And if you go into that directory and you load index.html into your web browser, you should see this. Oh, I see, you're asking about this?
Yeah.
Click on the file name. Click on utils.py.
Oh, I'm not even getting that. I'm getting JavaScript.
Are you running inside Binder? Are you running in this kind of Jupyter? Yeah. Okay. So the trick is, if you go up to your URL, you'll have an edit somewhere. Replace edit with files in the URL, and then it'll view it rather than. Okay. Do you see it? Does that work? Okay. It's kind of a hack when you're running things locally running things remotely to do this. Okay. So, okay. So basically, what I've shown you, and I'm not sure I've convinced anyone in the room that this is easy, but I've written some functions named test underscore. They set up a specific condition and run the functions in my code on it. And I'm doing really, really, really simple stuff. As soon as, after people get over the idea that they get to the idea that they want to run tests, that they want to write some tests, they immediately get blocked on like, what should I run? What should I test? And the simplest answer is the first answer is test the stuff that so obviously should work that you don't think you need to test it. Right? If you can't pass in a 5-character sequence and get the right number of ends out of that, then don't bother testing more complicated code, right? Because your code doesn't work at all. So the principle of testing is start with the simplest, dumbest sounding tests, the ones that absolutely should work, that really are literally no more than reading what the code does and passing in the conditions that should make it do that, and verify that that works. Those are called smoke tests, basically. And then code coverage is a good way to target additional tests by looking at your code base. As soon as you have more than like a dozen or 2 dozen lines of code, you're going to lose track of what your tests are actually testing. And code coverage is a way to go to look at code, find code that's not being executed by your tests. Okay, I'm going to show you one more trick and then we can break for the day. And that is this Virtualenv concept. And so Virtualenv is a really handy way for those of you that want to, there are 2 conditions. Okay, let me think about this. There are 3 conditions under which Virtualenv is really handy. One is the situation where you don't have super user privileges on the computer you're running things on. So imagine that you're running on like the Genome Center cluster and you want to install some Python packages, but you don't have systems administrator privileges. How would you do that? So Virtualenv will let you do that. Another situation is where you have some software that you need for one project and that software conflicts with software that you need for another project. So you don't want to install things globally because the package you're installing for project A will prevent you from installing the software that you need for package B. This happens when you need different versions of underlying libraries. And as soon as you start doing multiple things, it's actually surprisingly common. Like, I may have several different versions of a FASTA parser. That's a bad example. I may have several different versions of what's a good example of this, Travis? Where do we run into this?
Matplotlib.
Yeah, so Matplotlib. If I have different versions of Python, I need different versions of Matplotlib installed. So I want one for different versions of Python, for example. Although that can be handled, sort of.
It's a big
but it's annoying. Yeah. Typically, so here's a situation that I actually do frequently run into. Oh, I need a library to do X, Y, or Z. And so I go to PyPy, which I realize I haven't talked about. I go to the Python package index. And I'm like, hey, I need some code to parse JSON. I don't know. I want to parse some JSON files. And I go in and it tells me that there's like 50 packages, I'm assuming, to help me parse JSON files, whatever, right? And I do, there's a lot. Either there's a lot or the website's slow. And I'm like, well, I want to try one out. And I download it and I install it. And I decide not to use it. And then 6 months later, I find that it installed a bunch of stuff that it depends on that I don't actually want anymore, and installed it at the system level. So yeah, so you can see there's a lot of JSON parsing stuff. And if I want to try something, I don't necessarily want to install it at the system level or ask a systems administrator to install it at the system level. I might just want to try it in a small isolated environment that I can delete when I'm done with. That's a situation where Virtualenv is really handy. Go ahead.
If you have a virtual environment, can you like say you wanted to give like all your scripts that can run
Exactly.
like to someone else without having to teach them how to like say install Anaconda, version 2.7 specifically? Can you just give them a file that has that? It's all runnable.
So there's a couple ways to do that. Probably the simplest is you can write what's called a requirements file. And I'm not sure I remember how to do that. Let me see if I can whip that together for you. So if I am here and I have a requirements.txt file, traditionally named, I can put a package in. So let's suppose I put a package screed, which is a Python package that I wrote. I can say pip, I think it's -r requirements.txt. Is it? Okay. Google pip requirements file. Requirements pip install -r requirements.txt. Sorry. So if I now do, so I have this requirements.txt. I can do pip install -r requirements.txt, and we'll go through all of the packages in requirements.txt, and you can specify versions too. You can say screed equals 0.8, and it will go download just that version and install it. And that will work whether you're running in a Virtualenv or at the systems administrator level or at a Conda level, at a Conda package or an Anaconda or whatever. But the trick is you have to already be in the environment that you're right. So that's all. So
there's no way to transfer like a working environment to someone. They're complicated.
So let me just so what I would say is no, and you don't ever want to, right? Except for the situation where you're giving somebody a binary installer, and then there are things that will do that for you, right? But you never really want to be in a situation where you're like, hey, here's like a massive mess of binaries that I got to work together. Like, here you go. It's much better to have, you can actually ask pip to generate a requirements file from the list of installed packages that you have, I think. And so what you would do is you'd be like, hey, I got it all working. Now I'm going to extract the requirements into a file that you can then use to install exactly the versions that I had. That's a much better approach, because maybe they're working on a Mac and you were working on a Linux machine, then that would actually work, whereas handing them a bunch of binaries wouldn't.
So I just have a comment. I haven't done this actually, but I know that with Conda, if you do already have a Conda installed, right, you have this Conda package manager, which is also includes an environment manager, which is similar to the
Yeah, exactly.
But they do have an option where you can export your entire environment to a file, to a YML file, and then you can send
Environment
it
Danielle, yeah.
and someone who can just open it, I guess, or that's something.
Right. So
it could work.
So exactly right. But that's what that's doing is, again, it's giving them a list of the packages to install, not giving them the packages already installed. So it's exactly the same. It's better than actually in many ways, but it's essentially the same as a requirements file. So pip requirements or conda environment.yaml or whatever.
Yeah, at one point I was like, okay, I'm going to make a disk image for a virtual machine.
Yeah.
Dockers.
So now we get into, that's where Docker is something you should look at.
Okay.
And you know, this is a turtles all the way down situation. Like, I can spend 3 hours giving you options and demoing them for you. So if you're ever interested in doing this again, let's chat for 15 minutes and I can tell you what I think might be the right. Because so with Docker, you know, with the virtual machine and Docker and things like Docker, which is for containers, what you're really doing is you're saying, I don't just care about the Python. These aren't just Python packages. Conda and pip are primarily for Python. Here it's like, I want the whole, all of the dependencies, right? That's a much bigger question. And that's actually, I would say Docker is currently what I would recommend for that. So, and I have workshops on that too.
Are they upcoming or they're already?
There have been some, the materials are online. I can run another one if you're interested. But, okay, so actually what we are running in here is what I'm running in here on this binder environment is actually a Docker container running in Google Compute Engine somewhere else in the world. So it really is turtles all the way down. At some point you're running containers inside virtual machines on somebody else's machine in the cloud.
Yeah.
And you know,
it'd probably be better to run like that because you can install a bunch of crap that you don't really want to.
Hence the workshop approach. Yeah. Okay. So Virtualenv sound wonderful. Yes.
You left off repeatability.
Yeah, so there's repeatability and reproducibility issues where I can say, here's my environment, run exactly what I ran, do you get the same results? And that's good for science, I would argue. But, yeah. Okay, so Virtualenvs, they sound wonderful. How can we use them? So the only trick is you need to have the Virtualenv package installed. And if you're on a computer that you don't control, you don't have systems administrator privileges for, getting that installed can be a little bit difficult. Once you have it, but it doesn't require any privileges to run once you have it installed, so it's not really a security hole of any kind. So usually systems administrators are happy to install it for you. And what you do is you say Python -m virtualenv, and you give it a directory name. So let's say workshop. Okay, first you have to install it. And once it's installed, you can say Python -m virtualenv workshop. And what this does is it runs the Virtualenv library and creates a virtual environment in the directory workshop. And what this does is it mimics a Python distribution. So I now have a new Python program, workshop bin Python. And that's actually a Python executable that I can run that will import packages and so on from the workshop environment. How do I install stuff here? First, I have to activate the Virtualenv. I do that by doing .workshop bin activate. And helpfully, it modifies my prompt. You can see at the very beginning of the line, it now says workshop in parentheses to tell me that I'm now in the workshop Virtualenv. In here, I can install anything that I want. I can install pip install screed. I can say, which is again this package we use. I can say pip install coverage. I can specify specific versions of things that I want to install. I can install new versions of, I don't really know what else. I don't have a good example for this workshop ready, but I can do whatever I want that's pure Python. That's not pure Python. I can install any Python packages with pip within this, and they're accessible within this workshop environment. So let me install, I don't know, what should I install? That's funny because, you know, as soon as I leave this workshop, I will have all sorts of examples that I should have used.
Bio.
What?
Bio.
Yeah, so can I just do Biopython? Okay, so I'm installing Biopython, which is a big nasty package. It's running it. I don't have to have systems administrator privileges in order to do that. I don't have sysadmin privileges on this machine, I should say, that I'm running on. So I installed Biopython. I can now do, is it just bio? I can now import bio. I can see that it's actually loading the module bio from the workshop directory. And if I deactivate the virtual environment, I can no longer import it because it's not actually imported in my system's Python. It's only imported in my workshop Virtualenv. Travis?
Two things. First, what was the dot? I've never seen that.
Okay. So Travis is asking about this command, the activate command. So what dot does, it's equivalent to source.
Okay. Okay. So it's just source.
So what it's doing is it's activate is a shell script that modifies the environment. So you can't run it, you have to source it so that it modifies the environment that you're working in.
Yeah. Oh, you're doing 2.7 then. How do you do Virtualenv for?
Right. Okay. So the third use for Virtualenv is when you want to work with a specific version of Python, right? So throughout this workshop, I've been in a mess because typing Python, which is what I do reflexively, gave me Python 2. What I was intending to teach was Python 3. It's really annoying. Virtualenvs help you. So on my laptop, I typically work with both. And I switch environments. I switch Virtualenvs when I want to work with one versus the other. And I force myself. In fact, on my laptop, I almost always work within a virtual environment. As one example, my blog depends on old versions of Python code. And I don't update that virtual environment because I don't want to break my blog. But then I have a different virtual environment when I'm actually doing work. So I have Jupyter Notebook installed in a virtual environment. Anyway, so so that I have all the matplotlib stuff working. So the trick is you have to have Virtualenv installed for the version of Python that you want to run. So if I do Python 3.5 minus n Virtualenv, minus m Virtualenv. Okay, well, first of all, I have that problem. If I do this, Python 3 minus m Virtualenv, okay, Virtualenv is installed for Python 3, so I can now say workshop, let's make it workshop 3. And now if I do .ws3 bin activate, when I run Python, that should not have happened.
You have 2 versions installed.
So it's saying bin Python 2. Bin Python Virtualenv interpreter Anaconda Python 2. So your Python 3 is apparently alias of Python 2.
Wow. Okay, I don't know why that happened. Running Virtualenv with interpreter, home main Anaconda bin Python 2. Wow, all right, let me do this. User bin Python 3 minus m Virtualenv. Workshop 3. Okay, this looks like some weird Anaconda thing. Normally, this is what I use all the time. Normally, if you run Virtualenv with a specific version of Python, it runs. I don't understand what's going on here. Okay, well, so that's a total fail. Anyway, normally this should work. Yeah, sorry. No, only for Python. Yeah, sorry. What specific, what thing are you looking for?
So I've been trying to run a merge, and it requires both high voltage
Mm-hmm.
and
So if you're trying to run something that depends on different versions of older binaries, usually on shared compute systems, there's something like the module system, and usually you can load specific versions of binaries that way. Where are you running?
Right. On
Okay. So if they have the module subsystem,
yeah,
then you can do module spider, I think, to find old versions of modules, and we can help you. We can help you show you how to do that, because we run into this on on the high performance compute system that we run on, you know, we have some versions of software we use that are incompatible with others. So exactly that situation. Okay. Well, sorry. So sorry about, I don't know why this, I'm gonna have to dig into why this failed, but
Maybe a little bit of an content package.
I mean, I use all this software on a regular basis. This looks like a peculiarity of the binder environment specifically that just I didn't test in advance. So tell you what, I will break out of the Conda environment and go. Now I'll be really embarrassed if this doesn't work. If I do Python 3 minus m virtual and temp workshop, and I then activate that virtual environment. Now when I type Python, it specifies Python 3.5.1. Whereas if I exit this environment and I type Python, it's actually Python 2.7.11. So virtualenvs are ways that on my laptop I control whether or not I'm running within a Python 3 or a Python 2 system. And I actually have different versions of Python for testing some of our code under older versions of Python. And virtualenvs are how I do that as well. And I can make sure that all of my packages are installed under that virtualenv for a specific version of Python. So the last fun bit is, if you remember, just to sort of wrap around to some of the earlier stuff that I talked about. If you remember this this user bin env Python, what that command does is it looks in your path for a version of Python. So this is something that lets you work within virtualenvs easily. Whereas if you hard-coded user local bin Python or user bin Python 3 in there, it would only work on systems where Python was in user bin and it was the version that you wanted to use. So user bin, and that's why I put this at the top of the script, is because this links into whatever my virtualenv I'm running is.
When you say binder, sorry.
Sure.
And you're describing Jupyter, I don't really know if it's anything else. What do you mean?
Yeah, so let me go back one. So this environment, let me go up one. This environment that I'm running Jupyter in is, okay, prepare for some jargon. The environment that I'm running Jupyter in, it's actually running on a computer in Google Compute, the Google Cloud, inside a Docker container. And the binder is a combination of a GitHub repository that it copied into a Docker environment and then ran Jupyter on in the Google Cloud. So the binder ties all that stuff together. So it's the idea that here's a set of files, here's a compute specification, and here's Jupyter. Gives all of that to you. That's what I meant by a binder. So it's just the name of the app is mybinder.org. And generally, it's a reliable way to run workshops. I just failed to test a few of the things towards the end. All right, so I think I'll call it quits unless there are any other questions. Is there anything in the Etherpad that I'm missing? Yeah. So yeah, go ahead.
So I have a question about something that I think it's in my report that I think I understand the first time you said it, and then
Sure.
it was that if and then underscore name and then
Sure.
make that name. I totally don't remember how that thing works.
Okay, so here.
Yeah, correct.
So underscore name is if you're running this code as a script that is from the command line, you're typing Python space ndist.py. Underscore name is going to be set equal to the value main. So when you're running, this if statement is only true if this is being run as a script. If you import this file instead, then the name is something else. It's actually the name of the module. So the code inside the if statement won't be run in that situation. Won't be run if it's imported. So for example, in utils.py, these tests at the bottom are only run when you type Python space utils.py. If you import utils, that code, those tests are not run.
Yeah.
And so I had this example, foo.py, that showed sort of 3 different ways to execute code. Any statement that's just at the top level in a file gets executed. Any file inside a function gets executed. Any statement within a function gets executed when that function is executed. And the statement within the name equals main block gets executed only when foo.py is run from the command line. Okay. Well, yeah, let me know. Want to go over again?
Basically, name is just something that's defined at a point when any file is read, or
When any code is being executed, __ name is defined by Python. In a module, it's defined as the module name, unless it's a script, in which case it's defined as __ main.
__.
So there's another really handy one.
So sorry.
Go ahead.
So when you go back to so __ name is not something you're defining.
No, it's defined by,
Okay, that helps me.
sorry, yeah.
Because I was like, I thought we were defining this variable.
No.
And it's going back and forth between these two.
Nope, it's defined automatically by
Same thing with file, it's defined, those variables that have that __ something __ defined by the system, you're not supposed to mess with them if it's a reading. So,
Yeah.
That's why when you made the module, you made a version. If you're making your own, yeah, that's why versions is done that way.
Yeah, so some things are defined by Python for each file. So if I ran this, what you would see is Python 3 foo.py, and it would say I am in foo.py, but I didn't actually put foo.py in the code. I just said I am in __ file. Okay. All right. Well, so and this comes in handy for, the reason I had to talk about it was because it comes in handy for things where you want to differentiate between importing and executing. I'll just go in here.
Yeah, I kind of get that. The reason why you do it. I just
Yep. Yeah, syntax versus, yeah. All right, well, we welcome feedback. I don't know, I'll close this down now. Wow, that's, no, that didn't work. I want to, there we are, okay. So we welcome feedback on whether this was useful, and both from people online and people in the room, and keep in touch, I guess. So thanks for coming.